The Today in Manufacturing podcast offers a powerful and unique perspective on the biggest stories impacting U.S. manufacturers. Anna Wells, David Manty, and Jeff Ranke apply their experience as editors of industry-leading brands Manufacturing.net and Industrial Equipment News in providing in-depth analysis of the latest headlines. Their insight, along with a mix of humor and human interest, makes Today in Manufacturing a go-to source. Keep pace with supply chain challenges, electric vehicle developments, labor struggles, robotics, and more by listening, downloading, and subscribing to the Today in Manufacturing podcast.
Researchers at Southern Illinois University Carbondale, Go Salukis, have come up with a way to make 3D-printed food out of plastic waste. They call them microbites, and they could be an innovative answer to global problems over waste plastic and food scarcity. The process is fairly straightforward. The team mixes waste biomass and plastic, which is processed into slurry. A special yeast converts the slurry to proteins that are 3D printed into various forms, like cookies. The team, led by Assistant Professor Lahiru Jayakody, recently received a $25,000 grant from NASA's Deep Space Food Challenge. The challenge hoped to uncover novel food technologies that could feed astronauts on long, potentially one-way missions. But, like many other technologies created for the space race, this one could have a huge terrestrial impact as well. NASA insisted that the process fit into a tight envelope so astronauts could realistically use it on a shuttle or remote space station. The researchers say the process requires minimal space, uses water efficiently, and has a modular design, allowing users to change the product's nutrient composition. A big part of the process is the ability to depolymerize plastics without creating toxic chemicals or carbon streams using a biological process. That hungry yeast. But to get the yeast to eat the biomass in plastic, the team uses a process called oxidative hydrothermal dissolution, invented about 10 years ago by former geology professor Ken Anderson, now director of SIU's Advanced Energy Research Center. OHD uses water, heat, pressure, and oxygen to turn the biomass in plastic into water-soluble carbon molecules that the yeast will eat. As a proof of concept, the team 3D printed cookies and conducted a taste test with humans, or terrestrials, if you will. Overall, the food received pretty high marks, particularly the smell. The cookies scored a 6.5 out of 9 on the hedonic scale, the most widely used measure of food acceptability. According to the team, that's the highest known score for cookies made of repurposed waste biomass and plastic. Still, challenges remain, like getting the public on board with eating waste-derived food. But the team hopes to ramp up development with additional government funding and/or industrial partners that could help build a fully integrated and automated µBites system. Jayakody says, quote, "Food insecurity is a global and severe problem that affects millions of people, and it will increase as climate change becomes more severe. µBites," he says, "can provide food in extreme climates and resource-scarce regions, like submarines, Arctic labs, maybe even Mars. The technology can also be a backup plan for remote missions if and when resupply efforts are cut off. So, in our dystopian future, we won't have to eat people. We'll eat plastic garbage." I'm David Manty. This is Manufacturing Now.